Okay, frames of reference, which we're going to shorten here to FOR. Frames of reference are critical to relativity. And you can see up here we've got a little cartoon of a person in a train or car, very crude one, my apologies, moving this direction over here. And then a person standing on the ground here. Now the person standing on the train is doing just that, they're standing. And the person standing on the ground, again, is just standing. But to the person standing on the ground, it looks like the person on the train is moving. But to the person on the train, when they look out the window, they'll be seeing this person move past them. So who's moving? Who's correct? And this is the basis of relativity. And the key thing there is in the word relativity. The movement is relative. Let's break this down a bit further. And to do that, we need to understand frames of reference. Now, in frames of reference, there are two types, inertial and non-inertial. Inertial reference frames are ones that involve no acceleration. In other words, the object is remaining at constant velocity. This is otherwise known as Newton's first law of motion, the law of inertia, hence the name inertial reference frame, which states that an object will keep moving at constant velocity or at rest unless acted upon by an unbalanced external force, which we're going to call a net force. A non-inertial reference frame, in other words, is something that doesn't meet this criteria. In other words, you have something that's accelerating. That obeys Newton's second law, F equals ma, where you can see that there's an acceleration in this equation. If there is no acceleration involved, you can see that there's no net force, and then you have an inertial reference frame. Where do these two things sit into relativity? Well, Einstein actually postulated two different theories of relativity. The special theory of relativity and the general theory of relativity. And they cover both of these frames, both of these topics. Okay, in this course we're only considering special relativity, so we'll only be referring to inertial reference frames or studying those. Any reference frames that are inertial, non-inertial, my apologies, fit into general relativity, which is a totally different theory which allows for accelerating frames of reference. Okay, so what is a frame of reference? Well, it's all about your viewpoint. Where do you stand and what do you see? So if you see something moving relative to you, then that thing will see you moving relative to it. So it's just about which frame of reference you're in. In other words, in which frame of reference, which situation, are you still? Are you stationary? That's the best way to think about it. The other thing that we're going to mention here is that in special relativity, the maths is a lot simpler. In general relativity, the maths gets much more complicated. So much so that Einstein took several years to learn just the mathematics needed to formulate his theory that he wanted. So he didn't really know how to get to his answer. It took him many years of hard work at university to understand the mathematics. Some examples of inertial reference frames are things like standing on the ground here on Earth, just standing still. That would be no acceleration involved there. Another reference frame there would be driving in a car at constant velocity, such as on a highway, already at the speed limit and staying there. Okay, constant speed. Otherwise, you could also talk about being in a spaceship in space and just moving at constant velocity, constant speed. All of those involve no acceleration. Similar to those, if you were standing but in a lift accelerating upwards in a building, that would be a non-inertial reference frame because you are accelerating upwards. Another situation there could be in a car but turning a corner. You might remember from circular motion that by changing your direction of movement into a circle, you're actually changing your velocity, and a change in velocity is an acceleration. So circular motion actually involves general relativity and involves an external force to turn your path into a circle. Or in a car, going around the corner, you need to input a force to turn the corner. Or you could be in free fall, literally falling towards something, because free fall involves an acceleration due to gravity, okay? So in those situations, you would be in a non-inertial reference frame. And over here, you'd be in an inertial reference frame. Okay, so now just for some interesting parts of this, this topic, frames of reference. Where did it come about? Well, it actually didn't start with Einstein. It actually started with Galileo. Galileo in the 1600s, and another giant of physics, Isaac Newton. Now, the interesting thing about these two giants of physics is how contrasting their opinions of frames of reference were. Galileo suggested the following. He did a thought experiment involving a boat. Okay, so he had a boat and he imagined a cannonball being dropped from the top of the mast of a boat. Now, the boat is in motion, okay? The boat is moving this way. All right, so let's look at the situation of the frame of reference on the boat. We are standing on the boat. If we look up to the cannonball, we will see the cannonball fall down the mast like that, with that arrow just drawn here being its path of motion. However, if you were standing on the beach watching the exact same event, on the beach, watching the boat go past you, so it's moving from here to here, you'd see the cannonball start here, and then the cannonball would be at the bottom of the mast, but the boat has moved. So if you draw the path of motion for that, this arrow here is curved, as opposed to going straight down just because it's dropping, it's accelerating. Don't get confused by that. But have a look at the different arrows. The cannonball has travelled a different path, but it's been only one cannonball being dropped. They're not two different cannonballs. One cannonball being dropped from the top of the mast to the bottom one. And the path that it's taken depends on your viewpoint. And Galileo recognised this. So Galileo was the first one to discuss relativity and frames of reference, and this here is called Galilean relativity. We don't necessarily need to know that for this course that we're doing on special relativity, but this is where relativity has its origins. Now, Newton came along and he said the only frame of reference that matters is the frame of reference of the Earth. Okay, as it turns out, he was wrong, but he had an opinion and he didn't really do much with it, but at the time, Galileo and Newton were very contrasting in their opinion of frames of reference. Now, no one really understood the significance of this, so it sort of lay idle for 300 years. And then Einstein came along. And in 1905, uncovered his theory of special relativity. In it, he was the first person to understand the significance of frames of reference in relation to the speed of light. He was the first person to actually connect those ideas